Your car idles rough. You feel it in the steering wheel, through the seat, through your hands at every red light. You took it to the shop. They replaced the spark plugs, they swapped the coils, they checked the fuel pressure and told you everything was fine. The rough idle came back within a week. What they never touched, what nobody ever touches, is a sensor so small you can cover it with your thumb. A sensor sitting quietly in your engine bay, and right now, it is lying to your engine control unit with every single breath your engine takes. This is not a sensor most people have heard of. It is not the oxygen sensor. It is not the mass airflow sensor. It is buried deeper in the idle control system, and when it fails silently. No dramatic codes, no flashing lights, just a shake that gets worse when the heater runs, a roughness that doubles when you turn on the air conditioning, and an idle that hunts and surges like the engine cannot decide what it wants to do. Shops misdiagnose this one more than almost anything else on the road. Today, I am going to show you exactly which sensor it is, why it causes shaking and not much else, and how to fix it yourself for under $20 before a shop talks you into a $500 repair you never needed. Let's start where the shaking actually comes from. When your engine idles, it is doing something remarkably delicate. It is burning precise amounts of fuel in a precise sequence, generating power smooth enough to feel like nothing at all. That smoothness is not accidental. It is the result of dozens of systems working together in perfect coordination, all being orchestrated by one central computer, the ECU. The ECU does not guess. It reads. It reads airflow, coolant temperature, throttle position, and a dozen other signals, and it adjusts fuel delivery and ignition timing hundreds of times per second to keep the idle stable. When every sensor tells the truth, the idle is glassy smooth. When one sensor lies, the ECU chases bad data, overcorrects, and the engine shakes. Not all sensors fail loudly. Some fail slowly, drifting out of calibration by small amounts over thousands of miles. The ECU compensates. It adapts. It bends itself around the bad data, masking the problem just enough that no code gets set. Just enough that the engine keeps running, but not enough to keep the idle smooth. You feel the result every time you stop at a light. The engine trembles. Not dramatically. Not enough to worry most people. Just enough to be annoying, just enough to know something is wrong. The sensor responsible for this specific pattern is the idle air control valve, called the IAC. I need to explain what it actually does, so you understand why it is destroying your idle right now. Your throttle plate controls how much air enters the engine when you press the accelerator. When your foot is off the pedal, the throttle plate closes almost completely. Almost. It cannot close fully because the engine would stall. It needs a small amount of air at idle to keep running. That air bypasses the throttle plate entirely through a small passage, and the IAC valve controls exactly how much air gets through. When the engine is cold, it needs more air to run smoothly. The idle air control, or IAC, opens wider. When the engine warms up, it needs less air. The IAC closes down. When the air conditioning compressor kicks on and adds load to the engine, the IAC opens slightly to compensate and prevent a stumble. When you put the car in drive and the transmission load pulls the engine's revolutions per minute, or RPM, down, the IAC opens and catches it, keeping the idle from sagging and stalling. It is doing this constantly. Every second the engine is running at idle, the IAC is making tiny adjustments, hunting for the exact position that keeps the engine smooth. And it does this with a small electric motor or a small solenoid moving a pintle back and forth inside a metal bore. That bore collects carbon. Every engine produces carbon deposits as a byproduct of combustion. Those deposits travel backward through the intake, through the positive crankcase ventilation system, through the throttle body, and into the IAC passage. Over 60,000 to 80,000 miles, carbon builds up on the pintle, on the bore walls, and on the seat where the pintle contacts to close the passage. When carbon builds up, the IAC cannot move freely. A valve that is supposed to make precise, small adjustments starts sticking, hesitating, and jumping between positions instead of gliding smoothly. The engine control unit, ECU, commands a position change, and the IAC either lags behind or overcorrects. The idle swings up and down. The engine shakes. Here is the detail that traps every shop that misdiagnoses this. A dirty IAC valve often throws no codes at all. The engine control unit, ECU, monitors IAC operation, but it can only detect a completely failed valve, not a sticky one. A valve dirty enough to cause a rough idle is usually still moving enough to avoid setting a fault code. The computer sees a functioning component. The driver feels a shaking engine. The shop reads no codes and starts replacing other parts. I have seen this pattern more times than I can count. A driver comes in with a rough idle and a fresh set of spark plugs already installed. The shop before mine replaced them because rough idle codes often point to ignition. New plugs, new coils, and the idle was still rough the next morning. Then they replaced a vacuum line because someone spotted a hairline crack. Still rough. Then they suggested the fuel injectors needed cleaning and quoted a full injector service. At that point, the customer came to me. I pulled the IAC valve. It was covered in thick black carbon deposits. The pintle was sticky. I could feel it dragging when I pressed it by hand. I cleaned it, and the idle smoothed out before I finished putting the tools away. That customer had already spent $340 chasing a problem that needed 20 minutes and a can of throttle body cleaner to fix. Now I will show you exactly how to find this valve, how to test it before you remove it, and what the cleaning procedure actually looks like. There is a right way and a wrong way to do this, and the wrong way can damage the valve permanently. Finding the idle air control valve, or IAC, depends on your engine, but the logic is always the same. Follow the air intake from your air filter box toward the engine. The intake connects to the throttle body, a round housing with a butterfly valve inside. The throttle body is usually bolted directly to the intake manifold. The idle air control valve is attached to the throttle body, or mounted directly on the intake manifold nearby. It will have a small electrical connector with 2 to 4 wires. On older GM vehicles with port injection, the idle air control valve screws into the throttle body on the side facing the intake. On Honda and Toyota engines, it often mounts on the intake manifold with a coolant hose running through it to help warm the valve during cold starts. On Ford applications, it is commonly integrated into the throttle body assembly. On most modern vehicles with electronic throttle control, the traditional idle air control valve has been replaced by the electronic throttle body itself, which controls idle. I will address that in a moment because the cleaning procedure is different and equally important. Before you remove anything, do a quick test that costs nothing. With the engine cold, start it and let it idle. Watch the idle speed for 2 full minutes. A healthy engine should start high, around 1,200 to 1,500 revolutions per minute when cold, then gradually drop to normal idle, usually 600 to 800 revolutions per minute, as the engine warms. This should be a smooth, steady decline, not a straight drop, not a surge and hunts. If the idle hunts, meaning it climbs and drops repeatedly, that is classic idle air control contamination. If it drops too low and nearly stalls before recovering, that is the sticking pintle unable to open fast enough. If it fluctuates by more than 150 revolutions per minute at stable warm idle, the idle air control is struggling. Now turn on the air conditioning while the engine is at warm idle. Watch what happens to the RPM. A healthy idle air control will open slightly to compensate for the added compressor load, and the RPM will hold steady or drop by no more than 50 revolutions per minute before recovering. If the RPM sags dramatically, drops below 500 revolutions per minute, or causes the engine to shake noticeably when the air conditioning clicks on, the idle air control cannot respond fast enough because the pintle is sticking. That test alone tells you more than most scan tools will. Make sure the engine is cool. You are working near the intake manifold where coolant hoses may be connected, and you do not want hot coolant spraying on your hands. Disconnect the battery negative terminal first. Always disconnect the battery before you touch the IAC or any electrical connector. Leaving power applied can let the ECU record a fault or lose its idle calibration. Disconnect the electrical connector from the IAC valve. Press the release tab and pull the connector body firmly. Do not pull on the wires. If it is stiff, wiggle it while you press the tab. The IAC valve is typically held in place by 2 bolts. On most applications, these are 8 mm or 10 mm. Remove them carefully. Keep them in a magnetic tray. You do not want a bolt falling into the intake manifold. Gently pull the IAC away from the throttle body or manifold. There will be a rubber gasket or O-ring sealing it. Set the gasket aside and inspect it. If it is cracked, torn, or deformed, replace it. An IAC gasket costs $3 to $6. A vacuum leak from a bad gasket will undo everything you just fixed. Now look at the valve. Look at the pintle, the cone-shaped tip at the end. Look at the bore inside the throttle body where the valve seats. If you see black carbon, gummy buildup, or visible residue, you have found your problem. The cleaning procedure matters. Use throttle body cleaner for this. Not carb cleaner, not brake cleaner, and not WD-40. Throttle body cleaner is formulated specifically for plastic-safe, sensor-safe cleaning of intake components. Spray the pintle generously, letting the cleaner soak in for 30 seconds. Use a soft bristle brush. An old toothbrush works well to scrub the carbon deposits off the pintle gently. Do not use wire brushes, abrasive pads, or anything metal on the pintle surface. The surface needs to be smooth to seal properly. Spray again. Wipe with a clean rag. Repeat until the pintle is visibly clean and moves smoothly when pressed by hand. You should feel no resistance. It should glide. Clean the bore in the throttle body the same way. Spray, let it soak. Use a cotton swab to work the deposits loose from the bore walls. Spray again to flush the loosened carbon out of the passage. Use a flashlight to verify the bore is clean before reassembly. Inspect the pintle O-ring if your IAC uses one. Many do. A damaged O-ring on the pintle itself will cause a vacuum leak that directly affects idle quality. Replace it if there is any doubt. O-rings for IAC valves are available at any auto parts store for under $2. Before reinstalling, press the pintle by hand several times. It should move smoothly and spring back cleanly. If it still drags after cleaning, the internal spring may be weak or the bore may be worn. In that case, replacement is the right call. Reinstall with the gasket in place. Thread the bolts by hand first, then tighten evenly in an alternating pattern. Do not over-tighten. You are threading into aluminum or plastic. Snug, plus a quarter turn. Reconnect the electrical connector until it clicks positively. Reconnect the battery. Now comes the critical step that most guides skip. After reinstalling a cleaned or new idle air control valve, the engine control unit needs to relearn its idle calibration. The stored compensation values it built up around the dirty valve are now wrong. If you skip this step, the idle may feel worse for the first few days before gradually improving as the engine control unit adapts naturally. The proper relearn procedure for most vehicles is straightforward. With the engine fully warmed to normal operating temperature, shut it off completely. Wait 10 seconds. Restart and let the engine idle without touching the throttle for 5 full minutes. Do not touch the gas pedal. Do not run the air conditioning, the defrost, or the headlights. Let the engine control unit see the idle with the clean valve and no added loads. After 5 minutes, turn the engine off again. Wait 10 seconds. Restart and let it idle for another 2 minutes. The idle should now be noticeably smoother than before. Some vehicles, particularly Honda, Nissan, and older Toyota applications, have a more specific relearn procedure. For Honda, the idle learn requires idling for 10 minutes with all accessories off after clearing the engine control unit memory with a battery disconnect. For Nissan, there is an accelerator pedal position sensor reset that must happen before the idle relearn. If your idle does not settle properly after cleaning, look up the specific idle relearn procedure for your make, model, and year. Many manufacturers publish them in the service manual, and they are available free on most model-specific forums. Now, I will address electronic throttle bodies specifically because a significant portion of vehicles from 2005 onward have replaced the traditional idle air control valve with an electronic throttle body that handles idle control internally. If your vehicle has drive-by-wire, meaning there is no mechanical cable connecting your gas pedal to the throttle, you do not have a traditional idle air control valve. What you have is a throttle body with an electric motor that opens and closes the entire throttle plate under engine control unit command, including at idle. Carbon buildup on an electronic throttle body causes the exact same symptoms: rough idle, RPM hunting, and shaking when the air conditioning loads the engine. The cleaning procedure is similar, but requires more caution, because the throttle plate itself and the motor gear must not be sprayed with excessive cleaner. With the engine off and the battery disconnected, remove the intake tube from the throttle body. Use throttle body cleaner and a soft rag to clean the throttle plate and the bore. Work the plate open by hand gently while the battery is disconnected. Never force it fully open. Clean the deposits from the bore walls and from the edges of the plate where carbon accumulates most heavily. After reassembly, an electronic throttle body almost always requires a throttle position sensor reset and an idle relearn performed with a scan tool or by the specific key cycling procedure in your service manual. On many General Motors vehicles, this is done by turning the key to on without starting, waiting 10 seconds, then turning off and waiting 10 seconds, repeated 3 times. On Toyota, the procedure involves cycling the throttle before starting. Look up the procedure for your specific vehicle. Skipping it on an electronic throttle body often causes a worse idle than before you cleaned it. Prevention is simple. Clean the throttle body and the idle air control valve every 30,000 miles as routine maintenance. This takes 20 minutes and costs about $6 in cleaner. It is the single most effective thing you can do to maintain a smooth idle across the life of the engine. Replace your positive crankcase ventilation valve and related components on schedule. The positive crankcase ventilation valve is the primary source of the oil vapor that deposits carbon in your intake system on your throttle body and inside your idle air control bore. A positive crankcase ventilation valve costs $3 to $8 and should be replaced every 30,000 miles on most vehicles. A stuck open or stuck closed positive crankcase ventilation valve dramatically accelerates carbon buildup throughout the intake. The rough idle you are fighting right now may trace back to a $3 part that was never replaced. Check the idle air control electrical connector periodically. Carbon contamination is the most common idle air control failure, but connector corrosion is second. A corroded pin in the idle air control connector causes intermittent signal loss that produces the exact same hunting idle, but cleaning the valve does nothing to fix it. Inspect the connector pins for green or white corrosion. Clean them with electrical contact cleaner and apply a small amount of dielectric grease before reconnecting. Use quality engine oil and maintain your oil change intervals. Excessive oil consumption from worn piston rings or valve seals increases the oil vapor content in blow-by gases, which accelerates carbon deposition throughout the entire intake system, including directly onto your idle air control valve and bore. I watched a car come into my bay last spring, a 6-year-old vehicle with 74,000 miles. The owner had already paid for a full tune-up, new oxygen sensors, and a fuel system cleaning at the dealership. Total spent, just under $900. The idle was still rough every morning for the first few minutes. The shaking was pronounced enough that the driver was embarrassed to sit in traffic. The idle air control bore was packed with carbon so thick I could see it from 2 feet away. 40 minutes of cleaning, a new $4 gasket, and a proper idle relearn fixed it. The car idled perfectly on the first cold start the next morning. The owner called me to say it was the first time in 2 years the car had not shaken at a red light. $900 spent chasing the wrong components. 40 minutes and $4 to fix the actual problem. This is what makes the idle air control valve so dangerous to ignore. It fails slowly enough that mechanics without good diagnostic habits move past it. It fails silently enough that no code accuses it. It produces symptoms common enough to be mistaken for ignition problems, fuel problems, and engine wear. But it is none of those things. It is a small valve in a small passage, coated with the inevitable byproduct of combustion, doing its best to control your idle with a pintle that cannot move the way it was designed to. Clean it. Relearn the idle. Then clean it again at 30,000 miles before it ever gets this bad again. Your idle will tell you immediately whether this was the problem. Engines that have shaken at every red light for 2 years go glassy smooth the moment the idle air control valve can do its job again. Drop your exact idle symptoms in the comments below. Tell me when the shaking is worst, whether it happens when the engine is cold, whether the air conditioning makes it worse, and what your shop told you it was. I will tell you whether this is your problem. If you want more hidden fixes that dealerships make expensive and shops misdiagnose weekly, subscribe now. The next video exposes another sensor that destroys performance silently, one that most drivers have never heard of until the bill arrives.